So another alternative systems that we have discussed earlier that there are systems, the steps are major or core activities involved in systems development, but there are other alternative systems development. So one is object-oriented development. So I think programmers are very familiar with this one, but the object-oriented development would be another approach of developing an information systems, but still maybe following the processes that we've discussed before. But we only focus on the changes of the software development. Here we have more iterative and incremental than traditional structure development that we've discussed earlier, the structured traditional approach of the software development. But here, if we look at, there are three major processes here. We have systems analysis, which focus on interaction between system and user analyzed to identify objects. So instead of traditional documentation of the organization, we are looking at here at different objects. An object can be a person, a document, or a concept process within the organization. Second is they have design phase, describe how objects will behave and interact, group into classes, subclasses, and hierarchies. Because the main difference actually of the traditional software development is that they're looking at representing different entities into objects rather than separate entity, just like a structured approach. Last is implementation. Some classes may be reused from existing library of classes, others created or inherited. So there are approach here that some part of the system will be reused, and the orientation is different here because we treat each other as objects. So you can create a person as an object in an information system. So for example, if you are the human resource assigned for leave, so you can have the personnel object, and that personal object can create leave or can apply for leave, or can edit leave, or can apply monetization. So the orientation is object. Unlike the traditional approach, if you think of that, is you are thinking of a leave process in the structured approach. But here we are not. We define the user at this part, but we didn't think of them as an object as part of the programming stage. But here in the object-oriented, we think every interaction in the system are called objects, even if it's a person or concept, but these are all objects with their different characteristic. In some way, this organization of thinking in the systems development lifecycle would be easier for programmer to implement because we're thinking of everything as interaction of different objects, just like how the real world is being organized. And because reusable object-oriented development can potentially reduce time and cost of development. Because that means a human resource or a person can have the different characteristic. You can only add functions rather than following the entire process. And I think this is very hard for you to imagine, but that's how the orientation, while the structured approach is being organized into different process of the existing organization. Here we think of object-oriented development as creating different objects. You are just like creating a different world here with different objects being interaction, which would result to somehow the need of the organization. Let me check. And next would be the computer-aided software engineering. So common, when we develop a system, there's already a case or tools which defined as computer-aided software engineering. These are software tools to automate development and reduce repetitive tasks. So in the computer-aided software engineering tools, sometimes organizations will use existing interfaces. Especially, it's hard really to create a design interface, but here the case or the tools being used by the software engineering will be reused, and buttons, for instance, will not need to be coded but can be drag and drop only. So we have graphics facilities for producing charts and diagrams, so you might reuse existing ones. Screen and report generators, reporting facilities, so these are already tools rather than hard coding the reporting, but there are existing tools already that will produce the report that you're expecting. Analysis and checking tools, data dictionaries, code and documentation generator. Example in Java, if you want to document your programming in Java, it's already embedded on the programming works. So that means you don't need to write to create an entire documentation, because while you are programming, there's already a computer-aided software engineering tools that will assist you while creating the programs. It also produces an automatic documentation of what you're doing. But basically, this is initiated by the programmer itself. The programmer, while coding, is also writing the description of what they are coding, so that an ordinary user or other programmer can understand somehow. They have an idea of what they are doing, maybe front end or back end. What the author is been referring to. Front end is your interface, and the back end are the codes that works behind the program. So if you look at these slides, the PowerPoint, we are looking at the front end, meaning what the user can see. And the back end is actually when you click something and the system needs to respond to that click. That will be the back end side. We do not know what happened behind, but what we are looking only on the front end. And in fact, the programmers have different specializations. Some specializes on the interface only, meaning how it will appear to the user, and the other one is the back end and how the computer can efficiently compute or display the different things you want to display, or somehow how the program can be organized so that it can efficiently respond to the user needs. And lastly, support iterative design by automating revisions and changes and providing prototyping facilities. Somehow it's easier if you can use computer-aided software engineering, because imagine that you can already display or let the user see the initial interface if it's okay for them or not. So by using computer-aided software engineering tools, it makes easier for a programmer to display to the user or to show to the user what it looks like in the end, so that the user can appreciate the interface as early as during design stage of the systems development. So traditional systems life cycle, all this method of building an information systems, and another phase approach divides development into formal stages. So we have at least follows waterfall approach, task in one stage finish before another stage begins. So we have a traditional systems life cycle. It follows a waterfall. That means if after the analysis, you will move to the design. Systems analysis, you move to the design. That's the traditional approach. But somehow, you cannot skip from one stage to the other. So meaning you follow the traditional approach. Maintains formal division of labor between end users and IS specialists. So in the traditional software development, kasi, the end user is separate. The end user is not really part of the software development team, as I've described earlier. But in the recent software development practices, we already involve the user as early as this design specification of the system to avoid rework or more work for the programmer later. Then emphasizes formal specification and paperwork. That means focus on documentation. The programmer will always depend on the documentation, still used for building large complex system, and can be costly, time consuming, and inflexible. Other alternative systems development is prototyping. In prototyping, we build an experimental system, and this is inexpensive for end user to evaluate. So meaning, that's what I'm saying, using the case tools kanina, we can create a prototype, meaning an initial system that would describe or would create a graphical interface that would make the user evaluate if this is a good system or not. So we produce what we call this as prototype. That's why it's prototyping systems development. These are preliminary version of information system, and this can also be an adjunct system. We just need to create a system that will make the user imagine what would be the output of the system, and we work from that. Rather than showing the user the finished one, we will just create maybe initial functions and show the user if it's okay for them, so that we can proceed with the next step. This is to avoid, again, rejection of the system from the user type. And steps in prototyping will just identify user requirements, develop initial prototype, use prototype, revise, and enhance prototype. So this is a cycle, meaning, as I've said, this is an a prototyping, so meaning a cycle. We just start with the first prototype, we improve it, next another prototype. So the idea here is to involve the user every small stage of development of the system for them to approve and to imagine how the system will work. Because the problem here, actually the bottom line, is that the user sometimes cannot describe what he wants, especially if he cannot see or she cannot see the output of the system. But if you will create a prototype and the system can see how the system will work, actually the user sometimes can suggest more improvement of the system that would make the software development very useful to the individual or the individual user or the department as a whole, where the systems can be implemented. I'll skip that one, but this is the idea of the object-oriented system. So what's the advantage of prototyping? The useful if some uncertainty and requirements or design solution, and often used for end-user interface design and more likely to fulfill end-user requirements. So the advantage of prototyping is that if there are uncertain functionalities or interface that the user wants, it's already corrected as early as during the early development of the system. And the disadvantage is may gloss over essential steps and may not accommodate large quantities of data or large number of users, and may not undergo full testing or documentation because we focus on small steps on the system that can be implemented, visible to the user. We have also an end-user development. This is uses fourth generation language to allow end-user to develop systems with little or no help from technical specialists. So there are already existing easier software development tools. We still call them as case, where the user can suggest or can have drag and drop of the system that they want. So here, the end-user development would be more of the involvement of the user. And I suggest that if you're using end-user development, it would be focused on the interfaces rather than the hardcore or the back end of the system. The advantage is more rapid completion of project because user actually is very involved and contributing as part of the software development team. The advantage is not designed for processing intensive application, inadequate controls, testing, documentation or adherence to standards. Also, although there are steps that can be done to avoid the disadvantaged version of end user, but some organization is encouraging their users itself to suggest or to develop a functionality on their own as to be integrated in the system in the future.